Hello, discrete math fans. We're going to be using some special symbols for sets that we'll want to talk about all the time. Here's the list of very common sets that we'll run into. You have the set of complex numbers, real numbers, rational numbers, integers, natural numbers, and whole numbers. Now, as we'll see going forward, some of these are standard and some of these are not. When you draw them, it's sort of like a double bar on these things. You'll see me draw these in class on the board. You'll get a sense of how to draw these by hand. The way that it's rendered in the slides here is with a font that's called Blackboard Bold. So it's a particular type of bolding. Let's start with the set of real numbers. It's hard to give a real formal definition of the real numbers, but we'll appeal to some of your intuition to say that the real numbers contains all numbers, positive and negative, fractions and decimals, rationals and irrationals. All right, so the set R contains things like 17, negative 3/4, e, pi, log 5, square root of 3, stuff like that. Now the set Q of rational numbers, that contains fractions of integers. Of course, we don't ever allow 0 to be a denominator of a fraction. So here are some examples. Negative 3/4, 7. And then you might say, well, 7, is that really a fraction? Sure, I can write 7 as 7 over 1. 0.01. Now you might say, now wait a minute, that's a decimal. Is that a fraction? And you can actually say, yeah, that's a fraction because I can write 0.01 as 1 over 100. How about 0? Well, 0 is the same thing as 0 divided by a million. So as long as you can write the number as an integer divided by an integer, then it's a rational number. We use Q for rational numbers, Q for quotients. We can't use R for rational numbers because we're already using R for real numbers. Now, square root of 2, that's an example of a real number that's not rational. And we're actually going to prove that in this class. That's much later on. Then we have Z for the set of integers. That contains all natural numbers and their negatives and 0. And we could write it like this. Z is the set that contains negative 3, negative 2, negative 1, 0, 1, 2, 3, and then keep going on either side. All the negative whole numbers, all the positive whole numbers, and we're also going to include 0. The symbol Z, that comes from the German word Zahlen, and that just means number. We're not going to use an I for integer. I is kind of a funny letter to be using as a symbol. Okay, N, the set of natural numbers, that contains all positive integers. Okay, we could write that N is equal to the set containing 1, 2, 3, 4, and so on. Now, some books will include 0 as part of the set N. We're not going to do that in this class. Now we have the set W of whole numbers. That contains all the positive integers, and it also contains 0. So W equals the set containing 0, 1, 2, 3, 4, and so on. I should warn you that this is not a widely used symbol. When you pick up a math book, they might have a completely different definition for N, or they might not define W at all. So both N and W, depending on who you talk to, might mean different things, so be careful. I would say that the definitions we gave of R, Q, and Z, those are standard in mathematics. I would be very surprised to find a different definition. Now, in order to talk about complex numbers, we have to introduce the symbol I. All right, so this is, as I said, this is a funny symbol to be using as a variable. Now, in the real numbers, you can't take the square root of negative 1. That is to say, no matter what real number you square, you're never going to get negative 1. So what we do is we're going to create a symbol I and pretend that we can take the square root of negative 1. So this symbol I, it has the property that if you square it, you get -1. Then we can say that the set of complex numbers is the set of all numbers of the form a plus bi, where a and b are real numbers. I think the symbol C is also a standard symbol in mathematics. Now you can modify some of these symbols by putting superscripts on them. If you wanted to talk about the set of positive real numbers, you would denote that with an R and then a superscript plus. Superscript is like an exponent. Another modifier you can use is the star superscript. So if you want to talk about the set of non-zero rational numbers, you would denote that set with Q and then a superscript star. And these modifiers, this plus and the star, those are also fairly standard symbols in mathematics. Okay, that's all for now.